Welcome to Interchapter F. In Interchapter F, we're going to talk about more compounds that have suffix-changing functional groups. You can see the specific functional groups that we're going to talk about in this lecture shown here: the carboxylic acid, the ester, the amide, the acid anhydride, the nitrile, and the acid chloride. First, let's start off with carboxylic acids. Again, here's our outline on how to name organic molecules. The first thing that we're going to do is determine the suffix. For carboxylic acids, the suffix is oic acid. That means that the parent chain must contain the carboxylic acid, and that we have to number the parent chain so that the carboxylic acid has the lowest possible number. Let's look at some examples. Here we have butanoic acid. Butanoic acid is 4 carbons long. That's where the but comes from. The carboxylic acid has to get position 1, and we have a methoxy group at position 2. We also have pentanoic acid over here on the right. Again, the carboxylic acid gets number 1, and that puts a bromine group at position 3. You can see another example of a pentanoic acid here with a methyl group as position 4. And here's an example of a molecule that has 2 carboxylic acids. This becomes a dioic acid because there's 2 of them. Also notice that now we had to add an E because we're using the di. So don't forget it's pentanoic acid, but if there's 2 of them, then it would become pentane dioic acid. In this case, to determine which carboxylic acid gets the 1, we number from the left, 1, 2, 3, and from the right, 1, 2, 3. Well, there's a substituent in both directions, so we're going to use that ethyl group to break the tie because E comes before M alphabetically. Now let's look at salts of carboxylic acids. In basic solution, carboxylic acids can get deprotonated, and when they do that, their suffix changes from oic acid to O8. We also have to indicate the salt, if that's known. So for example here, the sodium refers to that counter ion there. And for potassium, we're also indicating the counter ion. In the left example, we have 1 carbon, which is why it's a methanoate. And in the right example, we have 2 carbons, which is why it's an ethanoate. It's also important to highlight the Greek lettering system for carboxylic acids. You may already be familiar with this because we've used this terminology a lot. But when we have a carbonyl carbon, we refer to the carbon next door as being alpha. That's why amino acids are often called alpha amino acids, because that amino group is attached to that alpha carbon. In this right case, we have a beta keto acid because the ketone is beta to the carboxylic acid. When we talk about reactions of carboxylic acids or carbonyl groups, you might hear me say that they occur at the alpha carbon or at the beta carbon. Occasionally we have reactions that will occur gamma or delta, but that's rare. Now we're going to talk about acid halides and acid anhydrides. Acid halides have the suffix oil halide. You can see in this example here, we have a bromide, so it becomes a butanoyl bromide. The 1, of course, has to be on the acid halide with a methyl group at 2 and a chlorine group at 3. Here's another example. 2 carbons, so it becomes an ethanoyl chloride because it's an acid chloride. Acid anhydrides have the suffix oic anhydride. And we name both sides of the anhydride. In our first case, on the left here, we have 2 carbons on the left and 2 carbons on the right. So we can just say ethanoic anhydride, and that assumes that we have ethyl groups on both sides. However, if we change the number of carbons, we have to specify that. 2 carbons is F, and one carbon is meth. And the only reason we say ethanoic methanoic is just because E comes before M alphabetically. Next, let's look at nitriles. Nitriles have the suffix nitrile. The carbon of the nitrile is included in the parent chain and must be number 1. If you see the example compared to propanoic acid, we have 3 carbons in the chain here, and the carbon of the carboxylic acid is included in the chain. The same thing happens with nitriles. The carbon of the nitrile is included in the chain. In this case, we have a 4-carbon chain, so it becomes a butane nitrile. It's also important to recognize that we have to use that E before the suffix. Here's another example here. We have 5 carbons in the parent chain, so it becomes a pentane nitrile, and we have a methyl group at position 4. And finally, let's talk about esters and amides. Esters also have the suffix -08. They're named very similarly to our carboxylic acid salts in that they have the same suffix. Just instead of a salt at the beginning, we name what's attached. So in this case, we have ethyl ethanoate. The ethyl refers to what's on the other side of the O. The other 2 carbons refer to the O8. In phenylpropanoate, the phenyl group is in front because it's attached to the oxygen. And then the 3 carbons of the propane chain are in the propanoate. In this right example, we have a methyl group attached to the O, and 1, 2, 3, 4 carbons in the main chain, so it becomes a butanoate with a bromine at position 3. The suffix for amides is amide. Here's an easy example here where we have 2 carbons in the chain, so it becomes an ethanamide. In this middle example, we have 4 carbons in the chain, so we have a butanamide with a chlorine attached to carbon 4. If we have any groups attached to the nitrogen, we start naming them as we do for amines. So in this case, we have a 3-carbon chain, 1, 2, 3. That's where the propanamide part comes from. And then we have a methyl group attached to the nitrogen. That's where we get the N-methyl part from. This slide summarizes all the suffixes of the functional groups that we've gone over this semester. And you can see a couple of notes. Remember that for carboxylic acid salts, the suffix changes to -08, but we need to add the name of the salt in front of the name of the compound. Also note that anytime these compounds are cyclic, the suffix is probably going to change. Notice that everything we've covered in this lecture is going to have a higher priority than alcohols, amines, alkenes, or alkynes. So we're going to have to break this down a little bit further to determine the priority between our carbonyl compounds. Don't forget that the trends that we learned before are going to hold true. So if we have increased bonds to an O or an N, those are going to have increased priority. Also, if we have bonds to oxygen versus nitrogen, oxygen is going to have priority. And if we have a bond to an H over an R, that's going to have priority. You can see in this table a summary of all of those things we talked about. Let's make sure that this works with what we said. And you can see that the nitrile, which has 3 bonds to a nitrogen, has priority over the amine that only has 1 bond to a nitrogen. We can also see that the ester, which has 3 bonds to an oxygen, has priority over the nitrile, which has 3 bonds to a nitrogen. And you can also see that the carboxylic acid, which has a bond to an H, has priority over the ester, which has a bond to a carbon group. All of these compounds also have prefixes that you can use if you need to. Let's look at some examples. So here's propanoic acid. Numbering-wise, the carbon attached to the carboxylic acid has priority. It has to have number 1. We don't have to put the numbering in, though, because the carboxylic acid by default is at 1, and there's nowhere else to put that double bond. Here's an acid chloride. The acid chloride is 1. And at 3, we have a triple bond indicated by the ine. In this example here, we have an ester. It's a methyl ester, so that's why there's that methyl in front. We also have the ester taking priority over the nitrile because it has 3 bonds to oxygen versus 3 bonds to nitrogen. So the nitrile turns into a prefix and becomes a cyano group at position 4. We have a 5-carbon chain, so we end up with a pentanoate. Don't forget that if you have any rings involved, they tend to change the suffix even further. So carboxylic acids attached to a benzene become benzoic acids. Esters become benzoates. If you had a methyl group for the R group, it would become a methyl benzoate. Amides become benzamides. Nitriles become benzonitriles. Aldehydes become benzaldehydes. And then, of course, alcohols become phenols, and amines become anilines. You don't have to know these, but this is a heads up in case you do see them. That concludes this lecture. Review the study guide and let me know if you have questions about any of the content we covered.